All right. Good afternoon, everyone. It's my pleasure to welcome you to our session today. Our session topic is SMR takes off AI wings. I'm Yujin An from McKinsey's office. I will be moderating today's session with our four distinguished speakers. Today's session is about generative AI and data center and power. So as all of you know, generative AI it has exploded over the last couple of years. And according to McKinsey research, it shows that it could create up to $4 trillion of value by 2030. So, but for that growth to happen, generative AI needs data center, and data center needs power than anything else. So this is going to be a big challenge for the data center and also power sector as well. So today, we are going to ask board question at the intersection of data centers' growing power demand and commercialization of SMRs. So we have around 15 minutes in total. And first, Dr. Wenke and Mr. Hellman will each give a 10 minutes presentation. And then we will move into the panel discussion about for 20 minutes. And then lastly, we will also open the floor for the question from the audience as well. So to set the stage, maybe we will start with the speech from Dr. Wenke.
Thank you so much. It is a great honor to be here at the 2025 World Knowledge Forum. And I appreciate the opportunity to speak with you about SMRs. I understand that we have not had a discussion about SMRs at this particular conference before. And it's also a great honor to be here on stage with my distinguished colleagues. It is a very normal thing in the United States for TerraPower and X-energy to be on the same stage talking about our businesses. So we get to do this very frequently. But we also have very important key partnerships here in Korea. Most, I think, long-standing with Doosan and Doosan Enerbility's team, which I'll talk more about briefly. But also, as of the last 2 weeks, a new partnership with KHNP. And so it is a privilege to be able to speak alongside colleagues from KHNP and Doosan. Let me start by recognizing that the room has probably varying experience with nuclear and SMRs, but Korea has great depth of experience in nuclear. Let me begin by just a little bit about the technology itself. People say SMR, and we like to joke that SMRs are in fact sometimes small. They are all reactors, and right now none of them are modular. But we do intend for them to be roughly small modular reactors. And what they really are reactors that are intended to allow for the components to be manufactured in a setting like Doosan has capability to do, in a repeatable fashion so that the price comes down and is delivered at a reliable schedule and cost to the customer. It should allow for heavy modularization to be employed so that you can deliver projects around the world in a repeatable fashion, and ultimately opening up the market by being in a smaller bite size than today's reactors. There are very few countries that have successfully deployed reactors and come down the cost curve. And KHNP has done that with their various technologies deployed here in Korea and abroad. But what we have seen in the United States is that there are very few customers that are capable of carrying the capital cost required for a very large reactor. And that has driven the market towards small modular reactors as a solution. Among the various SMR technologies out there, there are many different flavors, and you'll hear about two of those leading technologies today. We also have traditional light water reactors that are in a smaller size. And of course, Korea is developing one of those as well. X-energy's technology is a type of SMR called a high-temperature gas reactor. Now, this is an interesting technology for a number of reasons, but it really begins with the fuel, which is an encapsulated, very robust fuel form. It's made of ceramic material, and that ceramic material ensures that the fuel can never melt under any scenario in the reactor. So we start with a fuel that cannot melt and has extremely high tolerance to temperatures. And then we design our reactor from the fuel out so that in the worst case accident scenario, with no operator action, the reactor always ensures safety, that there will be no major radiological release. Now that's a great story to tell, but it's driven by the physics of the reactor. And what that means is that you get to simplify the design substantially. Today's reactors have 20 plus safety systems. They are marvelous feats of engineering, and they're incredible machines once constructed. What we're working on is a simpler design that only has 6 safety systems. And that means that you open up the number of potential suppliers because much of the plant is no longer a nuclear plant. It's really made of equipment that supports the nuclear plant, but today comes mostly from the natural gas industry. So our technology is referred to as the XE100. It's an 80 megawatt electric reactor. We will typically deploy them in 4 packs, and there are some key functional differences with these reactors based on the technology that I just described. Because the reactors are able to go to higher temperatures, it means that the reactor coolant and the inside of the reactor, we use helium instead of water, and that helium is able to go up to much higher temperatures. It exits the reactor core at 750 degrees Celsius, and then we make very high quality, high pressure steam on the backside. And that steam, when deployed, can either go directly into creating power production, like you do today, of course, which gives you very high efficiency on the electric production, but it's also high temperature and high pressure enough to support the direct use of the steam in heavy industry. And what that means for us is it enables a new part of our total addressable market where we can provide both steam and electricity in a combined heat and power system to decarbonize the heavy industrial sectors of the world. Oil, gas, petrochemicals, steel manufacturing, aluminum, hydrogen production. And really, we're demonstrating that with our first project. So the other important feature that I think is worth noting is that in the United States, while there are many developers, I think now we're at over 75 different SMR developers in the US, we all know that it's an expensive business to bring a reactor to market. And TerraPower and X-energy are part of a program together sponsored by the US government called the Advanced Reactor Demonstration Program. That program provides our companies multi-billion-dollar awards to pay for half of our IP generation and half of the capex of our first facilities. That really was a key enabler for us to capitalize our company and bring this technology to market. So X-energy's first project is with Dow Chemical as the customer, and we're deploying this project in Texas, south of Houston, at an existing large polyethylene and derivatives manufacturing facility. So that facility exists today. It's been operating for 60 years, and it uses natural gas for steam and electricity. We're replacing that natural gas production with 4 nuclear reactors that will provide the steam and electricity to that manufacturing facility for the next 60 years. And we've never seen a company like Dow step into the nuclear business, but we're really excited because this has opened up for us a new addressable market that SMRs are able to deploy into, but that large reactors were never able to access in the past. Now, all of that is just the prep to say, I know we're here to talk about AI, and AI is the big demand boom that's dragging all of these companies into an accelerated posture to deploy reactors faster than we all expected. And our second project is capitalized by Amazon. They joined our company as a large investor, including taking two board seats, but they also have provided a substantial investment in our second project, providing the risk capital that supports the equity portion of this plant, and they're going to provide the offtake agreement for that project. And so together, what that is a signal from the largest, the second largest company in the world by revenue, Amazon, taking substantial capital risk on a project because they believe that SMRs have to be a part of the solution in the 2030s to support their power growth needs and their ambitious decarbonization goals. So the end of that story really is the beginning, I think, of what we're here to discuss today. SMRs are a solution and a key tool. We're going to see continued rapid AI growth in the United States and abroad. But in the United States, it's so aggressive that it's really straining the US grid in a way that hasn't happened in many decades. And that's caused Amazon, as part of its investment in X-energy, to put out a 5 gigawatt electric target for deployment of our reactors by 2039. And that's just Amazon's initial minimum commitment to support X-energy projects. And each of these projects is targeted to be a gigawatt scale plant. So that's 12 of our reactors in one plant. And that means that we have to think differently about our company, and we have to think differently about how we deploy reactors. So that brings me to the last point I wanted to make here, which is the opportunity to work with Team Korea on the deployment of our reactors is critical. This country has been better than anyone in the globally aligned West at building reactors and deploying those. And it's a combination of the skill of project management and engineering services and the ability to manufacture very high quality products in your supply chain. And so it's been critical to us at our company to be able to have partnerships with, of course, Doosan and DLE&C over the last several years, who have been partners in engineering, modularization, and supply chain for X-energy. Now we are looking forward to the next phase of our work with Team Korea in partnership with KHNP in a recently signed MOU that occurred as your president came to visit the American president. And that's forming the basis for how we move forward aggressively into the market and as we move into the future to power AI.
Thank you, Dr. Reinke. Now we are here from Mr. Hellman.
Thank you very much. Well, thank you for having me here today. Again, my name is Steve Hellman. I'm the Executive Vice President and CFO at TerraPower. I joined the company a few months ago after a long career on Wall Street and as financial advisor to TerraPower. It's really an honor to be here in Korea and to be on the stage with such esteemed colleagues. It's very difficult for a finance guy to follow a PhD nuclear physicist, but I'll do my best. We're very pleased with the relationships that we've developed in Korea. As some of you may know, SK Group is a major shareholder in TerraPower, as is KHNP, and we also have relationships with Doosan. Hyundai is also an investor in the company. So we look forward to a really long and productive business career in Korea and hopefully to build many reactors here. A little bit about the history of TerraPower. As you may know, TerraPower was founded by Bill Gates, the Microsoft founder. He founded the company in 2008, and at the time he looked at the nuclear industry, and as you know, Mr. Gates is a disruptor by nature, and he looked at the industry and realized that this is an industry that has not been disrupted in 40 or 50 years. We're building the same types of reactors that were built, after World War II with, not very significant evolution. And he thought that, we could build these reactors more safely and less expensively. The technology that he came to focus on is liquid sodium fast reactors. And we've been developing that technology for the last several years. As you may know, we have actually started building our first demonstration reactor in Kemmerer, Wyoming. We hope to receive our construction permit application from the NRC at the end of this year. But we're very deeply involved in the project. We've invested over $1 billion in the project and have several thousand people working on it currently. Our technology has several features which I think distinguish it from certainly older generation nuclear technology and some of that of our competitors. First of all, we believe the technology is safer than existing technologies. As I mentioned, it's a liquid sodium technology. As you may know, liquid sodium has a very high boiling point. it's something around 900 degrees. So the risk of a meltdown, the type that would have occurred in Chernobyl, for example, in the 80s, is much less likely to occur with a liquid sodium-cooled reactor. Our reactors simply don't heat to that level, so there's very risk of the sodium boiling over. We have passive safety features, and the reactor operates at ambient temperature. So there's no the reactor is not pressurized. So again, much less risk of a malfunction or a meltdown. It's a very flexible design. It can vary its footprint depending on the site and the needs of the customer. We have a two-part design where the energy island is separated from the nuclear island, and I'll talk about that in a minute. Also, we have energy storage, which enables us to increase the capacity of the plant and effectively load follow. The base capacity of our plant is 345 megawatts, but with storage, we can increase it to 500 megawatts, which is really important to our utility customers, particularly during peak hours of demand. The plant is more efficient. It uses less water, and it is a much more efficient design, and it will be less expensive to build. It uses much less concrete, less steel, and as I mentioned, it operates at ambient temperature. So the componentry has to be designed, or will only need to be designed to much less rigorous standards. As I mentioned, the first plant is currently under construction. We expect to load fuel at the beginning of sometime in 2030, and hopefully we'll turn the plant over to our utility customer, PacifiCorp, with whom we've signed a power purchase agreement recently. We hope to turn it over to them for operation in 2031. And with that introduction, let me turn it back to our moderator, and we can answer questions.
Thank you. Now maybe we will move into the panel discussion, maybe. So to kick off, maybe I would like to ask the first question to Dr. Wenke. Yeah. So power consumption, in AI data center is rapidly increasing. How can we incentivize more rapid deployment of SMR to meet the demand from these data centers?
It's a great question, and there are, I think, many topics we could dive into. But I'll tee up a topic that I know is near and dear to Stephen's heart, which is how we will ultimately finance these projects. SMRs have been something that have been providing promise in our industry for many years. That promise has to become reality in the early 2030s when our reactors are coming online. And the way that happens today is through very large government support. The type that our companies are receiving is very important to de-risk the first-of-a-kind plant. But we have to very rapidly get to customers that are willing to put risk capital on the table, and the type of way that we currently finance projects in the renewables industry and the natural gas sector in the United States. It's about whether or not there is capital to be deployed to take risk on these projects so that we rapidly come down the cost curve. That's a key feature of capital. The second key feature of capital is the investment required by the supply chain to be able to grow and meet our needs as an industry. There are many different suppliers that need to be successful, and their businesses will grow with our deployments. And what does that really look like? Well, I do think that there is a role for government to support the deployment of these projects. In the United States, you're seeing early movers in SMRs driven by the program that our companies are part of, with the Department of Energy supporting us in the deployment of our reactors. But we also have key investment tax credits on the table in the US. And the one thing that everybody agrees on in Congress today is to be pro-nuclear. there's not much people in the U.S. agree on anymore, right? I think you can see that. But Republicans and Democrats agree that nuclear has to be a part of the solution. And that has meant that while other tax credits have come and gone, the nuclear tax credits have stayed. And there has continued to be strong support for those. And what that means is that investors who put money into building these projects will have the government investing in these projects through tax credits as well, in a way that substantially de-risks our path to market. So I think globally we need to look at tools like that incentivize increased deployment of capital early, and then the market, I think, will take care of this.
Yeah, that makes sense. Maybe I would like to also bring in Mr. Hammond. So who can help us to better understand technological aspect of SMRs? So, Mr. Hammond, SMR are touted for, high reliability and also advanced safety. And do you think why it makes better suited to, meet the demands of SMR, the demands of data centers, especially, the siting constraints and also the operational demand from the AI data center compared to other technologies like renewables or other conventional power?
Thank you. That's a great question. And I think SMRs are a great solution, not just for data center users like hyperscalers, but also for utilities. As I started my presentation, I mentioned that the industry has not really evolved, in the last 50 years since the first plants were built. The AP1000, which is the workhorse of the U.S. industry, is a tremendously expensive plant to build in terms of the amount of steel and concrete that's required. After 9/11, all of the nuclear towers had to be reinforced against, the risk of planes flying into them. So now this new generation of SMRs will be much safer, much more reliable, simply because of the evolution of the technology, and much less expensive to build. Our new nuclear reactor, for example, the nuclear core will sit below ground. So we won't have to deal with the issues that an AP1000, has to deal with in terms of these prominent towers that sit in people's communities and, actually are quite an eyesore. It's a great solution for utilities. Our technology, as I mentioned earlier, has load following capabilities where we can flex our capacity from 345 megawatts, to 500 megawatts with our molten storage tanks. In addition, I would note that we have a very flexible footprint. It's not one design because, we can divide the nuclear islands from the energy island. And so I think that's very helpful for utilities, but it's also very helpful for data centers. And we can provide a behind-the-meter solution for data centers. And we can operate at the size and scale that these modern data centers require, which are, as you know, quite enormous in size. Benjamin mentioned that they're deploying X-energy's technology in 4-packs, and we're doing something similar, 2-packs, 4-packs, meet the needs, the different needs of our customers, whether they're utilities or whether they're data center users.
I have some follow-up questions. So you mentioned there are different types of SMR technologies, right? The third generation, first generation, depending on cooling type. Do you think for AI data center there is better technology for SMR reactors type? You think?
Well, let me go, and then I'm sure Benjamin will have a view on this. Look, I think, to be candid, I think hyperscalers and AI data center, users are relatively indifferent to the source of the energy. They want it to be there as soon as possible. They want it to be reliable. I think they prefer that it be green, and they want it to be as inexpensive as possible, right? And so I think they're not they're technologists, but they're not nuclear technologists. And they want to leave that issue to us. At the end of the day, they want to know that when they turn their data centers on, they're going to operate without hiccups. And I think that's a solution that I think that X-energy will be able to provide.
Yeah, I think that's a great point. And as Stephen said, well, I will say I'm biased, of course. So I think, but you have two great technologies here that are inherently somewhat different and can be well suited to different types of customers. What we know from our work with Amazon is ultimately that even though a hyperscaler deploys gigawatt scale demand, they don't do it all at once, right? You don't build 1 gigawatt of data centers and then turn them on. And we all know that nuclear takes some time to build. We're going to get better at it and faster at it, but it's still much easier to build data centers than it is to build a nuclear power plant. And so if you think about it that way, while a gigawatt scale reactor can be a great solution to a demand signal of a gigawatt, many hyperscalers are moving to new communities and they're building gigawatt scale plants and ultimately turning those on 160 megawatts, 320 megawatts at a time and scaling those up. And so solutions that are under a gigawatt are actually maybe more valuable because they can scale and meet that demand curve that matches AI deployment. The last thing about this topic I think that's key is safety. Now, hyperscalers in general, I believe, are smart enough to know that nuclear is extremely safe already today as it's operated. But when we've worked with Amazon, that is a brand that's very directly engaged with the customer. So as Amazon tells the story, they're very customer obsessed. At my house every day, there are at least 2 boxes that show up from Amazon. That might be because my wife and I have a bad habit of buying things from Amazon, but there are always Amazon packages at our doorstep, and that means that I engage directly with the Amazon brand on a daily basis. And that has led them to want to find Gen 4 technologies as opposed to Gen 3 for direct investment, because they want to ensure that if they're putting their brand behind a technology that ultimately includes their capital to deploy it, that it is ultimately one of the safest technologies that's out there.
So we have a couple of minutes left. Maybe we can open the floor for maybe one question given the limited time. So from the audience, if you have any question, we can take one question. So could you please raise your hand?
Hello, thanks for the speech. I'm from Seattle, Washington, and good to see a person from Bellevue. And I have a question because the biggest customers should be Amazon and Microsoft, as you guys said, which are the biggest powerhouse of AI and cloud computing, which is bringing the whole demand and the whole electricity frenzy. So is the next hub for the SMR going to be Seattle? Or as you mentioned, is it going to be Houston still, which was the traditional powerhouse like oil and gas power? And is it based on the demand, or is it more of a regulatory issue that is going to decide where it's going to be the hub?
Well, I don't know that Seattle is necessarily a hub for nuclear development. Our colleagues, our friends at X-energy are based, in fact, in Virginia, the Washington corridor, where there are a lot of data centers. Seattle is where our founder is from, and there's a lot of technology. Well-educated engineers are located. I would say Houston is unlikely to be the future base in as much as it's not a natural area for, I would say, talent in the nuclear energy space. I would also add that one of the challenges we face in the U.S. is not having built power plants in the last 50 years. There aren't a lot of nuclear engineers at all in the country. So arguably, we could see multiple hubs throughout the country developing and not in any particular area.
I would add to that maybe a slightly different nuance, which is our first project is in Texas. Our second project is actually in Washington State, in South Central Washington. And Amazon has its largest data center clusters near our headquarters, near Washington, D.C. But its second largest existing cluster today is in Northern Oregon. And so we'll wheel power from Southern Washington down to Northern Oregon to support their data center demand. In the Houston area, we anticipate building a lot of X-energy projects in the greater Gulf Coast because the combined heat and power application of our technology is perfectly well suited to oil, gas, both production, refineries, and then petrochems. And that's the largest cluster globally outside of the Middle East. And so we do see a tremendous amount of demand growth in the U.S. Gulf Coast region. So maybe both will be the answer to your question. And I think there will be other locations around the United States as well. There will continue to be massive demand growth across the U.S. And I think there won't be one area, but I think kind of many areas where plants will be built. Okay, thank you. So we are out of time now. Maybe that brings to our session to the end. A big thanks to our panelists who shared their view and perspective today. And also, I really appreciate all of you who joined the session today. I hope you have a great rest of the day and then see you again. Thank you.
Please give a round of applause for our speakers.